going to start off the number revision by looking at chapter 1. First section I have here are powers and roots. We example is 4 squared plus 5 to the power 4. 4 squared is 16. 5 to the power 4 is 5 times 5 times 5 times 5. When I'm trying to multiply that, I would go 5 5s to 25, 5 5s to 25, which is 25 times 25, which is 625, and just adding them together gives you your answer. The roots, the wee 3 in there means it's a cube root. So cube root of 125 is 5. Now I want to draw your attention to this one here. The cube root of minus 125 is minus 5 because minus 5 times minus 5 times minus 5, if I do this over at the side, 2 minus give you a positive, 5 5s are 25. So that's 25 times minus 5, which gives you minus 125. I also want to draw your attention here at this stage to the square root of 16. Everybody knows the square root of 16 is 4, but it's also minus 4, because if you think about it, 4 times 4 gives you 16, and minus 4 times minus 4 also gives you 16. So when you're ever finding the ordinary square root of something, make sure you've got 2 answers there. Another one would be the square root of 25 is plus or minus 5. You can write them out separately like I did with the 4s, or you can put a plus and minus sign in beneath each other. It means the same thing. Next example I have here is find the counterexample of when n squared is greater than n. Now counterexample means find an example where that is not true. Now if you think about it, if you had n to be 3, 3 squared is 9, so 9 is bigger than 3. Let's go for another one. If n was 5, 5 squared is 25, which is bigger than that. Now what I'm going to try here is I'm going to try a fraction number. So I'm going to try n equals 0.5. Now if n is 0.5, n squared is 0.25. And so 0.25 is certainly not bigger than 0.5. So that'll be a counterexample of when that doesn't work. I've got another counterexample down here. It says if x is less than 1, it's saying that x squared is less than 1. Now if we start putting a few numbers in. So if x is 0.5, x squared would be 0.5 times 0.5, which is 0.25. So that is less than 1. I want to try to pick an example of when it's not true. So what I'm going to choose here is I'm going to choose a negative number. If I choose x to be negative 3. Now negative 3 is less than 1. But negative 3 squared is 9, and 9 is not less than 1. So those are my 2 answers in there. So when you're looking for counterexamples, you're looking to disprove the statement and think in terms of your fractions and your negative numbers. Next example is a lot easier. It's find the sum of the first 3 consecutive prime numbers. Prime numbers start off at 2. The next prime number is 3. And the next one is 5. Remember, prime numbers are numbers that nothing else goes into. The only even prime number is 2. Now he's adding these up. 2 plus 3 is 5. 5 plus 5 is 10. Now, the next wee section I'm on now is factors and multiples. Factors are what goes in evenly. So for example, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. If I was listing factors, I would always do them in pairs, so don't miss any out. Multiples are the answers to multiplication tables. So the multiples of 12 are like 12 ones are 12, 12 twos are 24, 12 threes are 36, and they go on forever. Prime factors is what you're likely to be asked in the exam. Prime factors are when you repeatedly divide by the smallest prime number possible, so there's no remainder. So I'm going to show you what I mean by that. I'm going to take the number 288 and write it as a product of prime factors. Now sometimes people find it useful to write the prime numbers out so they see what they're dividing by. If that helps you, that's absolutely grand. If you don't need to do that, don't worry about that. So I'm going to take 288. And the smallest prime number goes into 288 is 2. So divide it by 2. 2 into 2 goes once, 2 into 8 goes 4 times, 2 into 8 goes 4 times. Now I'm going to divide that answer by 2. 2 into 14 goes 7, 2 into 4 goes 2. I can divide by 2 again. 2 into 3, 7 goes 3 times with 1 over, 2 into 12 goes 6 times. I can still divide by 2. 2 into 3 goes once with 1 over. 2 into 16 goes 8 times. I can still divide by 2. 2 into 18 goes 9. Now I'm dividing by 3. And 3. Now the question says write it as a product. Product means when you multiply it all together. So the product of that is 1, 2, 3, 4, 5 2s. Write it nice and neatly, 2 with a wee 5 times 3 squared. So that's a product of prime factors there. I'm going to now look at lowest common multiple and highest common factor, which is quite important questions. So for example, find the lowest common multiple, I'll start with the highest common factor because it's easier. Find the highest common factor of 128 and 144. So what I'm going to do, and you're doing the highest common factor, always list the prime factors first. So step 1, find prime factors. So you just do it the same way as I did up above there. So take your 128, divide it by 2 to give you 64, divide it by 2 to give you 32, divide it by 2 to give you 16, divide it by 2 to give you 8, divide it by 2 to give you 4, divide it by 2 to give you 2, divide by 2 to give you 1. You always finish when you hit 1 at the bottom. 144 now. Divide it by 2 to give you 7 and a 2. Divide it by 2 to give you 36. 2 to give you 18. Divide by 2 again. Divide by 3 and that. Now when I'm looking for the highest common factor, the next step is to circle the factors in common. So that 2 is common. There's another 2 common. There's another 2 in common. And there's another 2 in common. Now I've run out of 2's to pair that up with, and I've nothing to pair the 3's up. So I'm done. So the highest common factor is you've got that 2 paired up. You've also got another set of 2's and another set of 2's and another set of 2's. So the highest common factor is 4 times 4, 16. So step 1 is find the prime factors. Step 2 is to circle the common prime factors. Circle the common prime factors. And step 3 is to multiply each pair together. Multiply each pair together. Now, I want to draw your attention here to something that you don't do. You do not go 2 times 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 2. You only include the 2 once. So it's 2 times 2 times 2 times 2. The next thing I want to look at now is lowest common multiple. So it's find the lowest common multiple of, I'll just go for the same numbers, 128 and 144. So step 1 is again find the prime factors. Now you've already done that in the previous example, so I don't have to repeat myself here. Step 2 is write the prime factors. Write the prime factors as products. So what you're going to do here is go down each number. 1, 2, 3, 4, 5, 6, 7. So I'm going to write the first one as 2 to the 7. And the second number is 1, 2, 3, 4. So it's 2 to the 4 times 3 squared. Now for your lowest common multiple, so step 3, include each number to the highest power. To the highest power. So include each number to the highest power. Now what I mean by that is if you look at your two answers, you've got 2 to the 7 and 2 to the 4 times 3 squared. So I've got the number 2 twice. I include it to the highest power, so I include that one there. So it's 2 to the 7. Look at the number 3, I only have it the once over here, so I include that. So the lowest common multiple is 2 to the power of 7, which is 128, times by 9, and just work that out. 9 8s are 72, put down your 2, carry your 7. 9 2s are 18, 18 adds 7 is 25, put down your 5, carry your 2. 9 times 1 is 9, add your 2 is 11. Now, while I'm on this topic of factors and multiples, I want to have a look at how you find some more complicated square roots. So I want to have a look at this here. If you were asked to use prime factorization to find the square root of, say, we'll go for 7, 7, 7, 9, 2, 4. Now, what you're going to do here is you're going to first of all find the prime factors. So to do prime factorization, you're going to divide by the prime factors. The clue's in the name and it says use prime factorisation. 2 into 7 goes 3 times with 1 over. 2 into 17 goes 8 times with 1 over. 2 into 17 goes 8 times with 1 over. 2 into 19 goes 9 times with 1 over. 2 into 12 goes 6 times. And 2 into 4 goes twice. Divide by 2 again. 2 into 3 goes once with 1 over. 2 into 18 goes 9. 2 into 8 goes 4. 2 into 9 goes 4 times with 1 over. 2 into 16 goes 8 times, and 2 into 2 goes once. I'm going to divide by 3 now. 3 into 19 goes 6 times with 1 over. 3 into 14 goes 4 times with 2 over. 3 into 24 goes 8 times. 3 into 8 goes twice with 2 over. And 3 into 21 goes 7 times. I'm going to divide by 3 again. 3 into 6 goes twice. 3 into 4 goes once with 1 over. 3 into 18 goes 6. 3 into 2 goes 0 with 2 over. 3 into 27 goes 9. I'll divide by 3 again. 3 into 21 goes 7 times. 3 into 6 goes twice. 3 into 0 and 3 into 9. And I'll divide by 3 again. I think it goes in. 3 into 7 goes twice with 1 over. 3 into 12 goes 4 times. 3 into 0 and 3 into 1. I can't divide it by 3 anymore. It doesn't go in. 5 doesn't go in. So I'm going to try dividing by 7. 7 into 24 goes 3 times with 3 over. 7 into 30 goes 4 times with 2 over. 7 into 21 goes 3 times. Divide by 7 again. 7 into 3 doesn't go, carry it over. 7 into 34 goes 7 fours are 28, and there's 6 left over. 7 into 63 goes 9 times. Divide by 7 and divide by 7 again. So I now have written that number as, so 7, 7, 7, 9, 2, 4. It can be written as 2 squared times 1, 2, 3, 4. 3 squared times 1, 2, 3, 4. 7 to the power of 4. Sorry, there was 4 there. Now, what I want to do is I want to find the square root of this. Now, if you think about it, if you think of the square root of 2 squared, 2 squared is 4, the square root of 4 is 2. So the square root of 2 squared breaks down into a 2. I'm just going to take that a little bit further here as I'm writing the rest of the sum out. If you think of the square root of 3 squared, which is the square root of 9, which is 3. The square root of 4 squared is the square root of 16. Now, if you look at this one here, it's 3, square root of 3 squared is 3, square root of 3 squared is 3, square root of 7 squared is 7, square root of 7 squared is 7. 3 2s are 6, 6 times 3 is 18, 7 7 is 49. Now you go over to the side to work out that wee sum. So it's just 49 times 18, should be a bit of long multiplication here, doesn't do any harm to revise over it. 9 8s are 72, put down your 2, carry your 7. 8 4s are 32, add the 7, 39. Put down your 0 now because you're in the second column. 1 9s, 1 4s, and don't forget to add them all together at the end. So your square root of 77924 without a calculator is 882. Now, the other one I want to look at here is quite an advanced example, and it basically is, what is the smallest number that 288 must be multiplied by to get a cube number. So this is quite a hard one, to be fair. Again, you write out your prime factors. So 1, 4, 4 divided by 2 gives you 72, divided by 2 gives you 36, divided by 2 gives you 18, divided by 2 gives you 9, then a 3, and then a 1. So your prime factors are 1, 2, 3, 4, 5, and 3 squared. That's what that number's like. Now, I want all this number to be cubed. Now, if you look at your 2 to the 5, I could break that down into 2 squared times a 2 cubed. And I've got a 3 squared there. That number in the middle is already cubed. To turn this one into a cube, I need an extra 2. So I need extra 2. Now I'll turn that one into a cube number. This one here is not a cube number at the minute, it's the power of 2. So I need an extra 2 and an extra 3. So the extra number is a 2 times a 3, which is a 6. Now, these